Lesson number 7 deals with some specific types of factoring. So what I wanted to do first is I kind of just wanted to do a demo of if I had x squared plus 6x plus 9, what that would look like. So I'd have my x squared, and then my 9, I know they have to go like this. So that means I need to have an x squared that goes this way, and then one that would go that way. If I put in another one, I can now turn and put another x squared. If I put one going this way, I can now put in 2 more. If I decided to do another one going this way, again, I could put 2 more. And that leaves me with 3 of these red ones left and 1 more of these x's. So if I take this x and put it vertically, I now have this shape. So what is the length and the width of this figure? What's the length? What's the width? What kind of shape do we call this when the length and the width are the same? A square. So the figure that I get this time is I get a square. We call this a perfect square trinomial. And we can take that x plus 3 and we can rewrite it as an x plus 3 squared. So when we were multiplying binomials in the last chapter, we did do some of these questions, and we did talk about whether or not there was a pattern that we could see from going from an x plus 3 squared to the x squared plus 6x plus 9 without having to do the distributive property. So if I look at this, how do I get the x squared? How do I use this to get my x squared? X times x. So I square the x. How do I get the 9? Square the 3. So most students, when you ask them to do this, and this was one of the questions on your quiz, or similar to one of the questions on your quiz, they get the x squared and the 9. Most students, the first time around, forget the part in the middle. How can I use the 3 and the x to get me my 6? 3 times x times 2. Multiply them together and then double it. So let's see if that works for something else. If I had x plus 5 squared. So if I use what Raylan had said, we already know that first term and that last term, I can square the x and the 5. But according to Raylan, I go x times 5, which would be 5x, and if I double it, I get 10x. So the way that I can check this is if I go x plus 5 times x plus 5, that middle term I get from multiplying these two together. 5x and 5x, it works. Okay. So a perfect square trinomial is formed from the product of 2 identical binomial factors. Perfect square trinomials can be factored when you consider the pattern displayed. So this p plus q squared means I would have, what would I have for my first term?
P squared.
P squared. And what would I have for my last term?
Q squared.
And then how would I get my middle term?
PQ, 2P.
2pq. P times q, which gives me my pq, and then times 2. And then with my p minus q squared, what would my first term be?
P squared.
What would my last term be?
Q squared.
Positive or negative?
It's still positive.
It's still positive because if I take negative q and I square it, I'm going to get a positive. Okay? And then what would my middle term be? The middle term would be my negative 2pq. So my first and my last term are always going to be positive, no matter what. And then my middle term, oh, I guess I should put that as being positive then. So my first and my last term will always be positive. My middle term has the same sign as what was in my binomial. So the first term is the square of the first term in the binomial. The last term is the square of the last term in the binomial. And the middle term is 2 times or double the product of the first and the last term. So when we go about factoring these, we can factor them the same way that we've factored the questions that we've done up to this point, using inspection and decomposition. Or if we recognize that it is a perfect square trinomial, then we can look at another way of factoring. So how could we recognize, without putting algebra tiles together and showing that that makes the shape of the square, how could I use these 3 numbers and answer the question, is this a perfect square trinomial? Well, what do I know about my outside numbers? My first and my last number have to be what types of numbers? Perfect squares. So is a squared a perfect square? Is 4 a perfect square? Yes. So how do I figure out whether or not that middle term is the right middle term for what I have? So if we go back to what we did, if I have x squared plus 6x plus 9, I know that x squared is a perfect square. I know that 9 is a perfect square. How do I know that 6 fits in there?
You could square root 9, and if so, you get 3, and 3 plus 3 is 6.
Okay. So could I do the same thing with this one? Square root 5, I get, or sorry, square root 25, and I get, and when I multiply it by 2, I get 10. Okay. So if I square root 4, what do I get? And if I double it? So is this a perfect square? Yes. So then if I had to factor that perfect square trinomial, because I know it's a perfect square trinomial, take the square root of a squared, the square root of 4, and the sign in the middle was the sign that I put here. There's my factored trinomial. Or I could use my sum and product chart. 2 numbers that multiply to 4 and add to 4 ends up being 2 and 2. So you get an a plus 2 and an a plus 2. Okay, let's look at the next one. Is this a perfect square trinomial? Why not?
Because 6 is in the perfect square.
So 6 is not a perfect square number. When we're factoring our perfect square trinomials, we deal with nice numbers. If the 6 is not a perfect square, I don't try factoring this. Okay, if I look at C, is 4x squared a perfect square? Yeah, because 4 and x squared are both perfect squared numbers. Is 81 a perfect squared number? Yes. Okay, now this time, when I take the square root of 81, I get 9. And when I double 9, I get 18.
You're supposed to double it because it's 4x squared.
What happens when I take the square root of 4? I get 2. So I get a 2 and a 9, which the product of those would be 18. And when I double the 18, 36. So is this a perfect square trinomial? Yes. What would happen if I tried factoring it? What would I get for the first term? How many x? I know I get an x.
X squared.
Squared goes over here. Okay, so let's just start with the last one. What do I do with the 81?
You get a 9.
I get a 9. What sign would go in between? Subtract, because my middle term was
There'd be
subtract.
2 x's.
So I get 2, which again was the square root when I did this over here. Okay, look at the last one. Is this a perfect square trinomial? Why not, Tyrone?
Because the negative 16.
Negative 16 is not a perfect square. 16 is, but negative is not. Right? And if you, when we were talking about that before when I was showing you the picture, because I have to square this 9 or this negative 9, I will never get a negative last term. Okay, so in class example number 2, we're going to fill in the blank so that each of the following is a perfect square trinomial. So if I look at this, what's the square root of x squared? X. What's the square root of 100? 10. So to get the middle, what do I do with these two numbers?
Together times
Multiply them and then times by 2, and what do I get?
20x.
Okay, see if you can do the next 3 on your own, and then we'll look at them as a class. What would I get for my middle term in B?
20x. Negative 20.
A negative 20x. What would I get for C? How did you get 30x? So would it be 30x or would it be 60x? Because I'd have to double it. So I multiply them together and then I have to double that answer. Okay, so in D, you're not given the last term. You're given the first term in the middle. So what do I do with the first term?
Square root.
And what do I get?
3d.
How did I get the 24? What did I have to do to get 24?
3 times 2 and the square root of whatever.
So, oops, not times 24. So 2 times 3 times whatever the square root of that last term was has to equal 24. So 3 times 2 is,
6.
and 6 times what is 24?
64.
6 times 4. So what would that make that the last term? 16. Okay, so now in class example number 3, we're going to factor these, checking that they're perfect squares. So how do I check if this is a perfect square? What do I do with the 49x squared?
Square root.
Square root it.
7x.
7x. What do I do with the 1?
And 1.
Or square root it,
Yeah.
right?
Which would still be
And then how do I get the middle term?
7x squared. Or 7 squared.
Divided by
Divide by
7,
seven.
then divided by 2.
Not divide by 7. Multiply these two together, and then times by 2. And if I do that, do I get 14? How do I make it a negative 14?
Have a negative number.
So this is a perfect square, so now I get to write it like this. So we look at B. What do I do with the 16?
Square root.
And what do I get?
4.
What do I do with the 25x squared?
Square root.
And I get,
5x.
and then to check the middle term, I multiply these two together, which gives me,
20.
and multiply it by 2.
40x.
And to make it a positive 40x, I make this a positive. And then I square it. Okay. The only difference with the last one is when it's stuck in a fraction. If I square root 1/9, square root 1 and I get square root 9 and I get, so I get 1/3 times a. Square root 9b squared, and what do you get? 3b. If I take 1/3 and I multiply it by 3, what do I get?
You get a whole root.
I get 1 whole. And when I multiply it by 2, I get 2 wholes. How do I make it a negative? Negative in the middle. I will give you fraction questions to practice with.
That's cool.
Okay, I want to look at, actually no, that's where I'm going to stop. So the questions that I want you to practice with, question number 1, I will give you B, D, F, and H. Question number 2, we'll do the same ones, B, D, F, and H. And question number 3, we'll do that one differently. We'll do it A, C, and E. And I'm going to give you a hint on E. There's a GCF that has to come out first. Because when you look at E, the first term is a 5x squared, which is not a perfect square. But if you look at the next 2 terms, it's 10 and 5, which are all factors of 5.